Today let's start with Chapter 8, C Characters and Strings. This is the table of contents for this chapter, and everything that you can see bolded over here are mostly function names. Actually, I think they're all function names. So you can see there are a lot of new functions that we'll get to in this chapter, but do not be overwhelmed. This is not even the end of it. This is all of them. But do not be overwhelmed because these so functions that you see covered in the same section are somewhat very similar. If you're don't let these strange looking function names overwhelm you. They'll start making sense when we start looking at them and you start using them. So the start of this chapter is basically about characters and strings and the relationship between them. You already know much of that based on the hands-on sections and the arrays chapter that we already did. But I'll just quickly walk through some of the basics again. Processing strings and with it processing characters in strings. It's kind of a very fundamental task for computers. And the C standard library provides us with a lot of functions to process strings and characters, make changes, convert, process strings. So we'll look through a lot of those in this chapter. Okay, so this part you already know. I already showed you what the 256 ASCII characters are that we can fit into a character variable. You already did a programming assignment on that in which you generated the entire ASCII table. So you're familiar with characters that we specify individual characters in single code. So you've already done much of that. We've also used several special characters, so signs like addition, subtraction, asterisk, slash, the $sign. Strings compared to character, strings are written in double quotation marks that you also already know. You already know about how we mark the end of a string or the last character in an array of characters, and we do that by putting after all the useful characters, by putting a character after that called the null character, which is specified as /0, like the /n/t characters, kind of like that. So strings, you already know, are accessed via pointers to the first character of that string. And for that reason, it's perfectly appropriate to say that a string is a pointer, and specifically a pointer to the string's first character. So strings, we already said that, are treated as arrays of characters. And in the previous chapter, we also saw another way to declare a string. So we're already familiar with creating strings as character arrays from the arrays chapter. But we also saw that we can declare a constant string, one that doesn't change, and instead of putting it into an array, we can simply point a character pointer at it. And here are two examples for that. So the first example that you see over here creates character array color with 1, 2, 3, 4 plus the null character that is 5 characters long. And the other way is to specify the string as a character constant string and define a pointer that points to that string. Now here there is no array that has been created before that as such. And in both cases over here, the string consists of 5 characters, B, L, U, E, and the null character. Another way to, if we want to go the more traditional way, the way we have been dealing with other arrays, integer arrays, for example, you could also initialize the character array color using the, you could initialize it like this with these curly braces and specify each character as a character in single quotes. That is also perfectly fine. But obviously between this syntax and this syntax or this syntax, I think it's pretty clear which one is more readable and easier to understand and even shorter to type. Now, when you are putting a string into an array, you have to take care that the array is large enough to accommodate that string plus the null character, of course. When you initialize a character array at the time you define it, like we've done in this example and these two examples, that's not a problem because you can just leave the square brackets of the array, you can just leave those empty and just do your initialization, and your compiler will automatically infer the size that this array has to be to accommodate the string you are specifying in the initialization. And we've also seen how we can read in strings from the command line, and we can do that using the Scanf function. Simple way to do that is kind of like this, but so in this case, let's assume that word is an array of size 20, and we want to read in some input provided by the user from the command line. Now, another way to do that is this. And what is the difference between the two? Well, they both use the Scanf functions, but this one is willing to take any string until a space or new line character or tab character is encountered in the input given by the user. Now, the size of the array over here is 20. Now, if the string goes on and there is none of these characters that would let us take a break, you could overrun the size of the array, and that can become a problem. And to prevent that, you can specify the number of characters that you want to take in, that you want to scan in from the command line. You can put a limit on that, and that's what we're doing over here by specifying 19 over here. And it's 19 again because the 20th character is the null character. Now in Microsoft Visual Studio, we've already seen that this does not work. You cannot limit limit the size of the string you're reading in like this, because we don't have scanf. Instead, we are using the secure version of the scanf function, scanf_s. And in that one, instead of providing the limit for the string length over here in the format specifier, instead we provide it as a third argument. So in this case, that would be actually should be 19. Should be 19, not 20. 19. Okay. Oh, I forgot one character. So yes, so scanf will keep reading characters into the array until it finds a space, tab, new line, or an end of file indicator, end of file character. And like I said, if you're not careful and if the input given at the command line happens to be longer, your program might even crash. And that's whenever you're taking in a string from a user from the command line, you should always specify the maximum field width, the maximum length of the string. And saying this again and again, in order for a string to display properly, it must terminate with a null character. Okay, so let's start with the character handling library. So let's begin with that. So you're already familiar with what characters are. Characters are basically numbers. You can think of them as numbers, but when we treat those numbers as characters, we take a different meaning to them. We assign them meanings according to the ASCII table that we saw. Now the end of file character is different. That evaluates to the number -1. And here's a table of, actually, I think we'll go through all of these functions, almost all of these functions, in some of the code examples I'll show you. There's one exception, however, and that is the very first function, isBlank. This function is not available in Microsoft Visual C++, or in our case, Visual Studio. So here, brief descriptions of each of these functions. You can see that they are all structured kind of similarly. At least the first few over here, they all take a character as input, that is converted to an integer. And let me read some of these for you. So this function over here is digit. This returns either a 0 or a 1. Think of it as a true or a false. If the argument that you have provided is a digit, a number from 0 to 9, this will return a true, otherwise false. And then we come to the next function, isAlpha. IsAlpha is short for is alphabetical. So if the argument you have given, C, is a letter, meaning A to Z or uppercase A to uppercase Z, this will return a true, otherwise false. Then we have isAlNum. You might wonder what that means. Alnum is short for alphanumeric, meaning this will return a true if you have a number 0 to 9, or a letter A to Z, or capital A to capital Z. And I think you must begin to see how these functions are named. So the next one is X digit. X is short for hexadecimal. So this will check if the character that you're providing as argument is a valid digit for a hexadecimal number, which means all the numbers 0 to 9 and all the letters A to F, or capital A to capital F. You can check if the letter provided in the argument is a lowercase letter, I'm sorry, so A to Z. If it's one of those, you'll get a true value, or a 1 returned, otherwise a 0, false. And similarly, you have isUpper. We have that function that checks if we have a character capital A to capital Z in that range. And then we have some other functions, toLower and toUpper. We've already used the toUpper function a few lessons ago. So toLower will basically take any letter that you give it, lowercase A to Z, or it'll even take uppercase A to Z, and it'll return to you all the uppercase equivalent. I'm sorry, the lowercase, small a to a z, small z. And toUpper will actually convert lowercase and uppercase letters for any of them. It'll return the uppercase equivalent. Then we have a function called isSpace. This returns a true if the character you've given as argument is a white space character. What's a white space character? It's basically a character that you can't see, so something like /n, space, /f, form field, /r, /t, /v, vertical tab. For any of these, it'll return a 1 for true. Otherwise, a 0 for false. Then we have is control. This is short for control. This will return a 1 for horizontal tab /d /t, vertical tab /v, form field /f, alert, that's the bell /a, backspace /b, carriage return /r, and new line /n. Then we have is punct, short for is punctuation. Returns 1 if you have anything that is not a space, not a digit, not a letter, meaning things like the $, hash, parentheses, square brackets, curly brackets, semicolon, colon, percentage, anything like that. Then we have is print, and this will return a 1 if the character you're providing is a printing character, if it's something that can be seen as such in a document, which means all visible characters, including a space. And finally, we have is graph, which is any printing characters, but it excludes the space. A slight difference between these two functions. Okay, here's a slightly more explanation on some of these functions. So is digit will return a 1 if we have a character 0 to 9 in the argument. Is alpha if we have lower or uppercase A to Z letters. Is alphanumeric if you have uppercase, lowercase letters or digits as argument. Is X digits returns a 1 for any of these, any hexadecimal number digit. And this is a small test program in which we test run is digit, is alpha, is alphanumeric, and is hex digit. I'll just call this hex digit, for hexadecimal. Okay, the structure of this program and some of the programs after this is very simple. We include the new header file C-type in this case, which includes all of these functions, and we have a bunch of printf statements. Now, this is a single printf statement on 3 lines over here, and the next one, this is like split over 5 lines. If you're uncomfortable with this, it is perfectly fine to print out what you'll see. We could have done this easily with 3 printf statements. Okay, so if you're not comfortable with stuffing all of this into 1 printf statement, make 3 printf statements, okay? Or make 5 printf statements for this block. Okay, so let me just explain the structure over here. So we are printing out a bunch of strings separated by on different lines. So they're all separated, they're all on separate lines. So in the first line, we print a string. What string? This string, the first argument. Actually, the second argument to the printf statement. According to is digit, colon, space. And then we jump to the next line. And let's see what's happening here. Remember this? Remember this guy? This is a conditional operator, and what we're doing is we're checking, it evaluates this expression up here, which is the return value of is digit when we pass it the character 8. So it is if is digit will return either a 0 or a 1. If it returns a 1, this string will take the place over here. And if we get a false or the 0 value from isDigit, this string over here, this expression will be put in this place. And that happens to be this %s over here. So we'll see a string printed out on the second line that starts either with 8 is a or 8 is not a, depending on what value this function returns. And after that we have another string, digit. So this will be a sentence. 8 is a digit, or it'll print out 8 is not a digit, depending on what this function gives us. Okay, then on the next line, so we are up to here, we are up to the /n. We have 2 more strings that we have to print out. The first string is again either this string or this string, depending on whether isDigit, when hash is passed to it, whether it returns a 0 or a 1. If it returns a 1, this one is printed. If isDigit returns a 0, this second one is printed. And finally, the last string that you see over here is digit. So this will print out, this line will print out hash is a digit, or it'll print out hash is not a digit, depending on what this function returns us. And this is how all of the other printf statements after this are structured as well. So in the next printf statement, we test out the isAlpha function. And we test out the isAlpha function by passing it a capital A, a lowercase b, an ampersand sign, and the character 4. And the output will again look kind of like that. We'll have a bunch of lines that are printed out. The first line is according to isAlpha. It's just a string. And that's this %s. We jump to the next line because of the /n. And then we print out 2 strings. The first string is either this one or this one. And then this %s is just says letter. And so on. So what do you think? What will isAlpha return, a 0 or a 1, when we pass it a capital A? Well, capital A is an alphabetic character, so it'll return a 1. And we should see is a space letter printed out of this line. And then we get to the next line. And on that one, we print out, well, we pass b, lowercase b, to the isAlpha function. It's also letter, so we'll see b is a letter. Next one, we pass it an ampersand sign. That's not a letter, so we'll see ampersand is not a letter. And then finally on the last line, we'll see isAlpha of 4. So isAlpha, is it an alphabetical character 4? No, so we'll see 4 is not a letter printed out. And we do the same thing for, we try out a few arguments for the isAlnum function, is alphabetical or alphanumerical. So we try capital A, yes, it is an alphanumeric character. We try out 8, yes, that's also an alphanumeric character. And we try out hash, which is not an alphanumeric character. So we use the conditional operator again everywhere over here. We could have done the same thing with if-else blocks, but that would have taken us many more lines of code. So I hope you can begin to appreciate the availability of this conditional operator. Things that would be done otherwise on 4, 5, 6 lines of code can be accomplished on a single line of code with the conditional operator. And finally, in this example, in this function, in this piece of code, we try out the isHexDigit function. So isHexDigit returns a 1 as long as the argument is a digit between 0 and 9, or small a to small f, or capital A to capital F. Any digit we can use for a hexadecimal number. base 16 number. Okay, so this one for F, that'll be true. So we'll see this printed out, followed by this string. J is not included, is not a hexadecimal digit, so we'll see J is not a printed out hexadecimal digit. 7, yes, true. 7 is a hexadecimal digit. The $sign, dollar is not a hexadecimal digit. F, lowercase f, yes, that's included. So F is a hexadecimal digit. We'll see that printed out. We run this code and we'll see something like this as the output. So I hope this starts making more sense now. The printf statement is kind of stuffed. I understand that. Okay, so 8 is a digit. Hash is not a digit. Makes sense. This is the isDigit function. Then we check out the isAlpha function. A is a letter. Yes. B is a letter. Yes. Ampersand is not a letter. 4 is not a letter. Makes sense. The isAlNum function. Alpha numeric characters. So 8 is a digit or a letter. A is a digit or a letter. 8 is a digit or a letter. Hash is not. And finally, the isHexDigit function. F is a hexadecimal digit. J is not. 7 is a $sign is not. F is a hexadecimal digit. So in the following slides, this just explains the use of the conditional operator again. So this is basically taken out. So basically, what string gets inserted into the printf statement as a particular argument is determined by the conditional operator like this. If this evaluates to true, then it's this one. If it evaluates to 0, it's the other one. And this works out rather nicely. And then we had another set of functions. We had functions to check, first two functions to check if a letter is a lowercase or an uppercase letter. And for that we have the isLower, isUpper functions. So isLower returns a true if you give one of these characters as input, as argument, and isUpper returns a true if you give a character capital A to capital Z in that range as input. The toLower and toUpper are functions that give you, if you give an uppercase character as input, it'll give you the corresponding lowercase. So the output is not a 0 or a 1, like in the functions up to this point. And toUpper does the opposite. If you give a lowercase or uppercase character letter as input, it'll give you the corresponding uppercase letter. Also, should note, remember, you can give a number or a character as input if what you give is not a lowercase letter. The function will simply return whatever you gave as input unchanged. So if you give it, for example, a hash character or a $sign, these are not letters, or an ampersand, or an exclamation mark, a dot, a semicolon, a colon, any of that, anything that's not a letter and doesn't have a lower or upper, or even a number, a 0, 5, anything like that, anything that doesn't have an uppercase counterpart like letters do. And here's a test program for that. So I won't explain the use of the conditional operator again, but what we're doing is over here we're trying out the isLower function with a lowercase p that'll just return a 1. Yes, it is a lowercase letter. If you give it an uppercase p, that'll give you a 0. isLower for 5 will just return 5. Will just return a 0. It's not a lowercase letter. And exclamation mark as argument will give you also a 0. And similarly, we can run this for the is upper function. Try it for the for a capital D. Yes, that'll give you a 1. Is upper for lowercase d will give you a 0. Is upper for 8 will give you a 0. Is upper for dollar will give you a 0. And then let's try the 2 upper, 2 lower functions. So if you convert, if you pass lowercase u to upper, it'll give you back capital U. If you give it a 7 as argument, you'll get the 7 back. If you give it a $sign as input, you'll get the $sign back. If you pass capital L to the 2 lower function, you'll get a lowercase l back. And this is what the output for this code will look like. So U becomes a capital U, 7 stays a 7, dollar stays a dollar when you pass it to the 2 upper function, and capital L is converted to a lowercase l. And you can see the other ones, is upper, is lower functions. The is lower function, for example, so P is lowercase, capital P is not lowercase, 5 is not a lowercase, exclamation is not a lowercase. So it makes perfect sense, everything over here. Then we have these other functions, is control, is punctuation, is print, is space, is graph. So is space determines whether character is one of the following: space, /f, form feed, new line, carriage return, tab, or vertical tab. And so this is the same information from the table. Is control expands that to /t/v/f/a/b/r/n. It'll give you a 1 if you have any of those characters. Is punctuation returns a 1 with anything that is not other than a space, digit, or letter. So any of those other things that we use in strings. Is print gives you anything, it gives you a 1 for the space character and anything else that can be displayed on the screen. And is graph does the same thing but excludes the space character. And the sample program for that is structured similarly. We pass the new line /n character to is space, /t, percentage, to is control. To check out the is control function, we pass it /n, dollar, we try these out. To is punctuation, semicolon, capital Y, hash. I'll just show you the output to that. I won't go through these line by line. Is print, $, /a, and then we try out the isGraph function, and we give it a capital Q. We give it a space that should be false. Remember, false space is excluded from the set of characters that will return a true for the isGraph function. And here's the output. So new line is a white space character. This is the isSpace function that we're checking out. Horizontal tab /t is a white space character. Percentage sign is not. Then we check out the is control function. New line is a control character. $sign is not. Is punctuation. Semicolon is a punctuation character. Hashtag is a punctuation character. Capital Y is not. It's not punctuation, it's a proper letter. Is print. Dollar is a printing character. We can see that on screen. Alert /a is not. That's the one that gave us that bing, that alert beep on the computer. Is graph. Q is a printing character. Space is not a printing character other than space. Okay, then we have some functions that actually perform some conversions from strings to other data types. So this is getting more interesting. We have First two over here, string to LL. What do you think that stands for? So str, you can always guess, stands for string. To is to, string to, and after that you have something else. LL stands for long integer. ULL stands for unsigned long integer. Now it takes a string as input. That string should start with something that is a number, but after that there could be other stuff in that string, right? So here are these functions, and there's another one, string to D. What do you think that stands for? The D stands for double. So if you want to convert, if you have a string, somebody typed something, you want to convert that directly to a double precision floating point number, you can do that with the string to D function, string to double function. We also have a string to L, string to long function. We also have a string to unsigned long function. So if you want to go smaller, not a long integer, or unsigned long integer. So we have these other functions as well. But you can see it's getting more interesting because these are taking more arguments. So the first argument is, of course, a pointer to the string that you want to convert to a double, long, or unsigned long. This is something new, and I'll talk about that. And see, we have two pointer operators over here in all of these. Two pointer operators means a pointer to a character inside a string, not just at the beginning, but somewhere else inside the string. Okay. I'll show you some examples. Okay. So, like I said, function string to D converts a sequence of characters to a floating point, double precision floating point value. And it'll return a 0 if it is unable to make sense of the string that you're giving it. It has two arguments. First one is the string that you want to convert to a double. And the second one is a pointer to a string, specifically a pointer to some place inside a string. And for that, we use these two pointer operators, two asterisks. And that will be a pointer, that is a way for the function to return more than just the return value. It'll send back the location in the first string up to which it was able to convert characters into a double, and what it couldn't convert, it'll point at that location using this second pointer. This will become much clearer when I show you an example. So if you want to use the string to double function, this is what that might look like. So you have a return type that'll the return will be of type double in this case. You pass it a string, and you have to pass it this string pointer. Okay. So let's assume we have this example. We have a string, constant character string, call it string, character array called string, and it's not an array. I'm sorry. This is a pointer to a constant character string. And these are its contents. As you can see, it starts with a number, but after that, we have stuff that cannot be converted to type double. And we also create a character pointer called string pointer in this case. We pass both of those to the string to D function. So the original string containing the data we want to convert, and this character pointer that will point us to someplace inside this string up here. What place, I'll show you. Okay, so we call string to D over here. It returns us a double value, and what we'll do is this. So first we print out the string %s. We'll print out this whole thing over here. 51.2% are admitted. Is converted to the, and then on the next line we'll jump to over here, double value, and over here we print out a floating point number up to 2 decimal digits. And what is that? That is D, the return value from string to double. That is the double number it was able to read, to recognize out of this string. So 51.2. This will, and because we specified it as 2-digit decimal number, this will print out as 51.20 over here. Now after that it continues, and the string, and what is that string? That is that string pointer that we created. And where is that pointing at? This will be pointing at the first character that the string to D function could not make sense of for conversion. So this will contain, in this place will be printed, actually this here, it can't make of the percentage sign either. So this will point to here, to the percentage sign. So in this place over here will be printed %r admitted. And yeah, here's the output. So we use, what's new over here is that we use an argument to receive not just one return value from a function, but we pass it a non-constant pointer, and we let the function change that pointer to some place, in this case, to some place inside the string. And in our example, that is the location of the percentage sign. And these other functions after that work very similarly. So we have string to long, works the same way. I'll just jump straight to the example over here. So we have a very similar example to the previous one for string to D. So we have a constant character string called string. We have a string, a pointer called string, and these are the constant contents of it. -1, 2, 3, 4, 5, 6, 7 ABC. Now ABC we won't be able to convert that to a number. And we also define a character pointer called remainder pointer. This first part over here, we can convert to a long value, no problem. And that's what string to L will do. X will contain the number -1, 2, 3, 4, 5, 6, 7, and the remainder of the string over here, starting from character A that couldn't be converted to number, that we will receive back using this. In this, its location will receive back in remainder pointer, the character pointer over here. And we can print that out. First we print out the whole original string. Then we print out the value of X that we received from string to L. We print out the remaining string that couldn't be made sense of, that is ABC. And just to demonstrate that you can actually use the value of X to do some math now, we add 567 to it and print out the new value, which is -1234000. So this is now not just X is not a string anymore. We can actually do calculations with it. We can use it as a number. Finally, string to unsigned long works the same way. And I'll jump straight to the example. We pass this one an unsigned number. So you can see that's why I put that minus sign over there, because I want to demonstrate it works with negative numbers as well. So we have a constant character array, constant string pointed at by pointer string, 1, 2, 3, 4, 5, 6, 7, ABC. Obviously, 1, 2, 3, 4, 5, 6, 7 can be recognized as an unsigned long integer, and that's what will be returned into X by string to unsigned long. And the remainder will be pointed at, specifically character A is what a remainder pointer passed as second argument will point at. And we see the output over here. We print out the entire string first, 1, 2, 3, 4, 5, 6, 7, ABC. We print out the converted value, X, which is 1,234,567. And the remainder of the string we couldn't make sense of, ABC. And then we do some math. Again, we subtract 567 from X and we print out that value. Again, demonstrating that we can use it. It's now a number, it's not a string anymore, and we can use it to make calculations.